Good morning, students.
Good morning, sir.
How are you doing today?
I'm fine. You?
I'm pretty fine. I'm giving thanks. Could have been worse. Could have been very worse. So I'm giving thanks. All right, I want you to do me a favor, please. Can you just send out something in the group WhatsApp, please, to let them know, say, class start. We need to go, we need to go, we need to go. So just send out a message in the group for me, please, somebody, anybody. And so we can get the ball running immediately. Please and thanks. We're going to have a fabulous day in class today. Um, thank you, Riri. And Akeem, thank you. Please send me the link. Good morning, Mr. Akeem. Share screen. Are you all seeing my screen?
Yes, sir.
Nice job. All right. So I have a question projected. It says the limit as x tends to infinity of x to the fourth minus x squared minus 9x cubed all over x to the fourth plus x cubed. This is where we left off in class on Friday, on Thursday. So I'm going to ask that we start here. I want you all to do the work. I may call upon somebody in the class or anybody in the class to send a pic either in the chat or WhatsApp so I can project it so we can look at it and talk about it. So you have some warm-up questions. I have a few warm-up questions. So I'm going to ask that you start from it, please. I give you 3 minutes to work this question. There are only 12 of you here, and I know the class is a little bit more than 12 students. I plan to have a fabulous online class. I really hope that I can have your undivided and we can just really get through some stuff today. Let me see. I don't know your names, all of your names as yet, so you have to work with me. I remember Rian, and I remember Randine. Randine, you're the one that sit at the front, don't? I think that's Randine.
Yes, sir. I'm the one that's at the front.
Right, good. And I think I remember Malik. Malik, you're the one that in the that wear the glasses? No?
Yes, sir.
Okay, good. I remember Malik. And I know Akeem. I don't see Lisa. Lisa not here yet. All right. So I will get to the others over time. Um, so just help me out, please. Forgive me. So I'm gonna ask when whenever we're in our online classes, we don't know when it is that we'll be moving online. God forbid there may be a situation where I am just unable to come to the physical class and I will say, here the plan class. We're going to be meeting online. So it means that we will congregate in the event like such as that. Case in point, I have an academic board meeting that starts at 9 o'clock this morning as I sit on the board. But I choose to not go to that session and be at class today. So there are going to be 1 or 2 times when I may be required to do some stuff, but I will meet you online. So you will sit in class for argument's sake, and we'll use this modality. I'll talk to you, you see my screen, we operate just as if we're in a face-to-face session. At the end of the session, I will want to ask you some questions about the online delivery. As you know, we move into the next era. Online is really where most educational institutions are going, especially the ones that are offshore. So I'll ask you to give me your feedback as to the online delivery. Let me go back and see how best I can improve. I have spent a lot of money to invest in all of what you're seeing on the screen so that I can reach you and you can understand what is happening. So at the end of the day, I want you to critique me. I want you to be critical. Let me know, sir, this not work. Or sir, it worked. Trust me, I won't feel any way. This is only going to help me. All right. So you have 2.5 minutes left to finish up this question. I'm going to mute. Oh, one other thing. When I call upon the class, I'm not teaching persons who cannot speak. When I call upon you to speak, I'm going to ask that you unmute and just speak to me. All right. All right. Thank you for joining and thank you for understanding and agreeing. And on the mark, get set, go. 2 minutes left. Is anyone finished? Anyone wants to volunteer their answer so far? Does anyone want? How far are you? Anybody almost finished?
Soon, sir.
All right, cool. Is there anyone in the class that does not understand at all what to do?
Yes, sir. Me.
Same, sir.
Donald. All right, Donald, I don't know.
Sir, I don't really know how to do this one.
Yeah, me too.
Okay. All right, you have to help me now. Donald. Is it your first class, Donald?
Yes, sir.
So yeah, even I expect you to understand it. All right, Octavia, it's not your first class.
Yes, it is.
All right. Cheyenne, is this your first class too?
No, sir. I came to the first class, but after the first class, I didn't get to come to the second one because I had some.
Oh, your voice sound like my friend who they are multiply something. I multiplied wrong. True or false?
No, sir.
I mean, no, you talk so strong. I know you sitting on the front of the class the last time.
No, I was beside Malik.
Oh, and you then. All right. You see, forgive me, and I'm just trying to. I know this is what my second week. This is the third class. So I'm just trying. Just some of the names I'm getting. Never mind. All right. Who is this VP person? Your names must be. I'm gonna ask that you put your names for the records of the institution. I'm gonna ask that you put your correct name. Alisa Vassal. Okay, but I'm seeing. Oh Lord. Cheyenne, I'm gonna ask you to put your last name for me, please. I want the full name on the stuff. If the full names are not there, I will have to drop you from the session. Please, it is for security purposes and as also for the record. So like John D, I don't know who's John D. Donald, put your last name for me, please. Brittany, your last name as well. Thank you. Abigail, I don't know your last name, and I'm sure it's not iPhone. All right, so let's go. All right, sorry, Malik, if you finish, Papa?
Yes, sir.
What you got for the answer?
1.
Big up yourself. Big up yourself. Very nice, Papa. Proud of you.
Sir.
Yeah. Lisa is going to buy you a bag of tigers. And make sure Lisa give you a bag of tigers. Very nice. All right, let's go. So I'm gonna work the question. I want those in particular who were not here to pay special attention as to what is happening. Remind me towards the end of the class, I have some housekeeping matters to deal with, all right? So I'm gonna do the limit as x tends to infinity. Remember now, what is gonna happen here is that an infinitely large number is a number that, as it says, is going to be very large. And when I raise that to the fourth power, it's going to be even larger than all the other numbers here. So I can safely say that this one here goes to infinity. And similarly, the infinity here goes here because this is infinity to the fourth power is a very large number. I can say this is indeterminate. So it's indeterminate. So it's indeterminate. So what I now need to do is to look for the highest term, meaning the term with the largest exponent, and that term is going to be what? What term?
X cubed.
X cubed? Is it x cubed though?
Sir, X to the fourth.
X to the fourth power. Very good. So the largest term, the coefficient is going to be x to the fourth. So what I'm going to be doing, I'm going to be dividing each term by that largest term with the exponent. So I'm going to divide each term by x to the fourth. So this is what I have, or will have. X to the fourth divided by x to the fourth. Minus x squared divided by x to the fourth. Minus 9x cubed divided by x to the fourth. All over x to the fourth divided by x to the fourth. Plus x cubed divided by x to the fourth. Now, this is where your business calculus rubbishness, your pre-calculus come into effect. I want you to recall a to the m divided by a to the n is equal to a to the m minus n. A to the m divided by a to the n is going to be equal to a to the m minus n. So it's going to be the numerator power minus the denominator power. All right. So in that case, what I do here is a cancellation. So this cancels into this and leaves 1. Do you agree there? X4
Yes,
into X, right.
Sir, can I go back over that for me, please?
Go back over what?
The part from the M over N equal AM minus N.
All right, so that is pre-calculus. That's one of the housekeeping matters I need to talk about today before we leave. So that's pre-calculus. So what it is that we're doing pre-cal, we say when we're dividing two terms in the same base, it's going to be the numerator power minus the denominator power. So a to the m minus a to the n, rubbish, sorry, let's go again. A to the m divided by a to the n is going to be a to the m minus n. It is going to be the numerator power minus the denominator power. It's the numerator power minus the denominator power. So a to the m divided by a to the n is going to be equal to a to the m minus n. So the base remains the same, but all I'm going to do with the powers is just subtract the numerator power minus the denominator power. So one way of looking at it, for example, x to the fourth over x to the fourth is going to be equals to x to the 4 minus 4. 4 minus 4 equals?
0.
And anything raised to the power 0 equals?
1.
Numero uno. Numero uno. Very good. 1. So that's how we got this one here in green over this side right here, because that's what we did. Let us look at another example. Say x squared divided by x to the fourth. Remember, the bases are the same, so I'm going to subtract my powers. Right at the base, it's going to be 2 to the 2 minus 4. What is 2 minus 4?
-2.
Good job. So I'm going to have x now, x to the -2. Uh-oh. Uh-oh. How do I do this now, sir? X to the -2. How do I do this, sir? Not a problem. I'm going to ask you to recall again for me. 1 over a to the negative m is going to be equals to a to the positive m. Or a to the negative m is equals to 1 over a to the positive m. So those are the laws of indices. You understand why we had to do pre-calculus before we give you guys business calculus? Because all of these laws must be remembered in order for you to evaluate many of these things, right? So when I have a negative exponent, all I need to do is reciprocate. So if the negative exponent is in the denominator, I will reciprocate it. It becomes positive in the numerator. If I have it in the numerator, a to the negative m, we reciprocate it, we get 1 over a to the positive m. And so it works both ways. We never normally write our index as a negative number. We always try to write it as being positive. And I know Mrs. Hall Francis would have told you that. All right. So that's how we do the stuff. So my other question to you now. So when I cancel x squared into x to the fourth, what do I have left here? X squared can go fully.
Is it
very
X
nice. Excellent. So I'm just going to have a 2 right here. And when can all of x to the third go into x to the fourth?
No, sir.
Think again. Can all of
Yes,
x
sir.
to the third and leave a remainder of what?
Yes, sir.
1.
Very good. So
1.
all of x cubed goes into x to the fourth. I'm just left with x to the first. And x to the fourth cancels x to the fourth and give me 1. And again, all of x cubed can go into x to the fourth and leave that remainder 1. So technically, my function is now reduced to the limit as x tends to infinity of 1 minus 1 over x squared minus 9 over x all over 1 plus 1 over x. Tell me if you agree with that.
Yes, sir.
Good job. Is everyone else seeing this? Students, I can't see you know.
Yes, sir.
Very nice, very nice. I can't see you know, students. So you have to be honest with yourself. Go again. Somebody was saying something. Go again, please.
Yes, I was saying that's what I have.
Good job, Brandine. So I really want you to be honest with yourself. If you're cheating the process, when we return to class on Thursday, God's willing, this is not what I'm going to go over. I'm not repeating any of this. I'm moving on. Matter of fact, I'm moving on today. I'm only doing this as normally what I do. At the start of each class, I try to step back, just one step back, so that I can, propel forward. So when I finish this and move on, come Thursday, God's willing, I am not on this. So I'm going to ask that you don't cheat the process and just pay attention. Don't want the distraction at home. Lock out the distraction, please. Put on the phone, turn off the TV, lock up in your room, or go into the bathroom, go lock up and just focus. If you're using your phone for class, that is fine. But I don't want the distractions, all right? We can do this. All right, so let's go. Now, what I want to show you here is, as I did the last class, just remember, as x tends to infinity, remember 1 over x squared, similar to 9 over x, similar to 1 over x, will all tend to 0. Because as x gets large, but the value in the numerator is remaining the same, the value at some point in time is going to go to 0. We did that exercise in class when we asked to do 1 over 2, 1 over 10, and got 0.2, 0.1. Then 1 over 100, it got 0.01. 1 over 1,000 got 0.001. 1 over 10,000 got 0.0001. So every time the value of x is getting larger, what is happening is that the overall value is tending to be a smaller number. So every time x gets large, the fraction itself works out to be a smaller number. So therefore, as x goes to infinity, and infinity is a large number, as x gets to infinity, it could be 1 over a million, it's going to be 0.000001. That's 0. So we can safely say that as x tends to infinity, all those fractional forms, what is important? In order for this to be true, what is important is that the numerator has to be a constant. Because if the numerator is not a constant and contains a variable, that variable in the numerator is also going to increase as x gets to infinity. And that's not going to go to 0. So it's very important that when you do your cancellations, and that's why it's also very important that you're going to be dividing through by the highest coefficient in the function. The highest coefficient in the function can occur both in the numerator and denominator, as in this case. It can only occur in the numerator alone, as we did last Thursday. It can occur in the numerator alone. So you have to be very careful. Look at the highest coefficient of the power, so that you are going to divide through by that. If not, you're going to end up with a term, with a variable in the numerator. You don't want that, because if you do have that, then this statement, as x tends to infinity, all of those go to 0, will not be true. The numerator has to be constant. Let me see how best I can use it in real life.
So basically you're saying all the denominator has to be x?
Or a variable in x. It don't have to be x. It could be x or x squared or x cubed or x something.
Okay.
If that's what you mean, yes. Let me show you in real life what is happening. You work in an organization, and for the last year and a half, 2 years, you're being paid $100,000 a month. Your take home is $100,000. When them take out them tax and everything, your take home is $100,000 a month flat. What your $100,000 a month could buy 2 years ago, can it buy the same amount today?
No, sir.
No, it can't. because your salary is not increasing. But the variables that you have to contend with, the light and the water and the cable, don't even talk about the cable, because every day them teething company, they put on a little $100 and $200 on the cable bill. And you start out with $3,000, and then after that, boom, it reach $5,000, $6,000, $7,000 for cable, right? And then the food and everything. So your money not increase, but everything else around is increasing. So you have less to get. This is exactly what it is with the limit right here. Something is held constant, but something is changing. So let's go. So all we have to do here now is to say the limit as x tends to 0, rubbish, infinity. I'm going to have 1 minus 0 minus 0 all over 1 plus 0. 1 minus 0 is equals to 1. And 1 plus 0 is equals to 1, which is equals to 1. So very good, Malik. My limit is 1. Any questions? Any questions?
Sir, could you please repeat what you said about the variables?
So as the variables increase, the fraction is going to go to 0. As the variables increase, the fraction goes to 0. As the variables increase, the fractions go to 0. Get that now, Lisa Boo?
Yes, sir.
Good. Any other questions?
Sir, so that's the answer. 1.
Yeah, man. 1. Yeah.
Okay. So I didn't get to do the homework now, just something, because I never understand how to do this, so I never get to do it, sir.
Okay, no problem. How are we otherwise though, guys? Are we understanding? Remember, it's important for me to know that you're understanding. Are we okay? Do we think we're getting it better now, better at it? Good job, Randine. Nice, nice, nice. Very, very good. Is there anybody in the class that absolutely don't have a clue? Okay, so Abigail is saying kinda. All right, Abigail, I'm gonna ask you to the other part that is not so clear to you, I want you to tell me so if I can explain it, because I have many more questions. I doubt I'm going to get through all of these questions that I have today, because I must move into another area. I have to move into another area. So what I'm going to do, I have 1, 2, 3, 4, 5, 6 questions here for you. 2, 4, 6. I've done 1. I may do 3 of the questions and leave you with 3 to do, maybe even as a class work or otherwise. And there's a little fun activity that I'm going to ask you to do. I'm going to go back to this, with what it is that we're doing here. So it is that we can, have some conversation. Now, here what I would ask you to do. Well, let me not even say that, because I want you to be able to follow. Abby, talk to teacher. What are you not fully understanding?
Sir, I feel it's really moral practice, especially with this one, with the infinity.
Mm-hmm.
I think it's mostly practice.
Let me ask you, Abby, and the rest of you listen to the question. If she makes a mistake, I won't correct her. You guys will come in and correct her, because I want to know that you're following. Abby, when I give you a limit to evaluate that tends to infinity, what do we do?
Sir,
How do we evaluate it? Go ahead.
you put it over the largest value, I think.
Okay.
Or something like that. I don't know if I'm saying it right, but yeah.
Is she saying it right, guys? Because I could fix it up a little better. Randy,
So
yeah.
you take the largest power over x, is it that way?
Yeah, Cheyenne, but guess what? Something else missing, man. Come on. both of you saying almost the same thing. I want it to be more granular, more specific. What are we doing?
Sir, you're dividing
Yeah, by what, Lisa?
by the largest power.
Yeah, for what, Lisa?
The fraction, sir.
Yeah, something missing, man. Something missing, man. Something missing. Where the man them there? Where the man them there? Come, help out the ladies, gentlemen. Talk to me.
Sir, is it in a case where you put all the variables over the largest divide by the largest
Okay,
x
don't
to
say
the
variables.
power?
Don't say variables, say terms.
So you're dividing all the terms by the largest x with the x with the largest power.
Very good, Shy. Very good. So that's what, if I get it right, Abby wasn't saying, right? So what it is, so it's each term. So it's not just dividing by the coefficient of the highest exponent. That's not just it. Because you divide by the coefficient, you have to specifically say to me, you're dividing each term by the coefficient of the variable of the coefficient, the highest coefficient. The variable of the highest coefficient, you're dividing each term. Look at what I have in my first line or my second line. It is x to the fourth is a variable with the highest coefficient. And I'm dividing it by each term of my limit. Can you see that?
Yes, sir.
Yeah, man. So yeah, man. So that's what it is. Please always bear in mind that that's exactly what we're doing. All right. So
Sir,
yes,
quick
ma'am.
question, sir.
Go
Do you
ahead.
say you're looking on the denominator or the numerator with the largest coefficient?
You're looking throughout the function.
So you're looking towards all the functions.
Yes, man. Numerator and denominator. Like remember, I said to you, I did ask the last class to write your summary. So remember, I said to you, that the variable with the highest coefficient can appear in both numerator and denominator. Then you get a particular answer. It can appear in the numerator only. Then your answer will always be a particular way. It can appear in the denominator only, and then your answer is going to be in a particular way. I did ask us a summary. There are 3 types, and I did ask for a summary. So let me give you one more like this to do for me, and let me see how well you can do it. I want you all to make an attempt. Please, don't want lazy man writers to take you over. But very good question though. It says to me that you are following. Are you all following what is happening here in the online session? Is my first online session with you. Are you all following? Can you see the board clearly? Am I speaking clearly?
Yes, sir.
Yes, sir.
All right,
Yes,
good.
sir.
Good job. Is anybody here so far that is not liking the experience? Talk to me. Let me know what is happening. All right. I'm going to take that as you're all following. All right. So this one here says 2x to the 5th minus 9x squared minus 7x all over 5x to the 5th plus 2x. I'm going to give you 2 minutes. I'm going to give you 2 minutes, and I'm going to ask you to evaluate that limit for me, please. Thank you.
Sir?
How we stay? Wow, Raheem, big up yourself. Congratulations. And so to Tatiana, and to Randy, and to Alyssa, and to Danica. Woo! Very nice. You guys are understanding. What about the rest of you? What about the rest of you?
Sir, my stuck.
Aye. Where? What happened?
After the part when me sir what me put everything over the thing and then do the calculation minus what to minus from whatsoever, sir, me stuck right there, so.
All right, let us see if I can do it. Very good, Malik and Makeda, Ryan, senior responses, excellent. Was it Shine a while ago talking to me? Help me out, please.
Yes, sir.
All right, I respect your honesty. And you will get it. Very good. Is this Jauna?
Yes, sir.
Very good, my love.
Sir,
Um,
same, I'm stuck too, sir.
Who said them stuck? Lisa, if I put it across my lap on BTC, where you stuck, Lisa?
Sir, the second part, sir. The second step, sir.
Lisa Boo. All right, come, let's go. Cheyenne, Lisa, is there anybody else? I love the fact that Lisa and Cheyenne are very honest. I don't want any student to in my class not understanding and don't say anything to me. You shouldn't be leaving a class and not learning. Is there anybody else in the class that is not understanding? Or stuck understanding but just get stuck somewhere?
Sir, me stuck too.
You stuck, Abby? All right, no problem. Let's go.
Sure.
Let's go. Can you identify the term for me? The variable with the highest coefficient?
X to the fifth.
Excellent. So the mere fact, Shane, that you see that you're on the right track. Abby, you saw that too? And Lisa?
Yes, sir.
Good job. Nice, nice. All right, so let's go. So we know that this is going to be indeterminate because we're talking about infinity. Good. So what we're going to say now is the limit as x tends to infinity of 2x to the fifth over x to the fifth minus 9x squared over x to the fifth minus 7x.
Sir, hold on, sir. Sir, so you don't put the number 2 beside the 2x to the fifth?
Shaheen,
Uh,
Shaheen.
Sir, because that's what I do.
All right, hold on, Shaheen. I could go back up here. So me just call the name and I never said no more. Cheyenne, look and see. Oh, true, the other one was just 1x to the fourth. No, man. Listen to what I
Yes,
said,
sir.
Cheyenne. I said that what you're dividing by is the variable with the highest coefficient. Not the number, not the coefficient. Not the coefficient, the exponent. It's not the coefficient that you're using. You're looking at the variable with the highest exponent. So no, now that I can understand where you make your error. So we're not dividing by the 2x to the fifth. No, man. Because in that case, what would you divide 1 here by? Right? So it's not that. It's just a variable with the highest exponent you're using. So this is now 5x to the fifth over x to the fifth minus 9x squared. Rubbishness.
No,
2x.
sir, something wrong.
A 2 don't.
Yeah.
Yeah, I'm
Plus
just
two.
yeah, boy, I tell you now, thanks here, done. I just put it there to see if Malik was paying attention, but Malik he wasn't because he never correct me. So all right, let's go. So now I'm gonna have the limit as x tends to infinity of 2 minus 9 over x cubed minus 7 over x to the fourth. Anybody agree with me so far?
Yes, sir.
Yeah.
Yes, sir.
All over 5 plus 2 over x to the fourth. Anybody agree with me right there, sir?
Yes, sir.
Yes, sir.
Yes, sir.
All right, let me just get this thing. Forgive me. Oh. Oh no, where did my stuff go? All right, hold on, I'm trying to find. Okay, hold on a minute, please. I'm trying to find my work. I have found it. Just let me just correct something here, please. X tends to infinity of 2 minus 9 over x cubed minus 7 over x to the fourth all over 5 plus 2 over x to the fourth. I feel very excited when students come to class and try and you learn. It's a very good feeling. So I'm happy that you guys are following. Those of you who are not following so far, please just talk to teacher. I'm here to help you, and I really want you to get it. Because you're being very good students today, the notes that I'm writing here, I'm going to share it with you in the WhatsApp group. Is that okay?
Okay, sir. Yes,
All
sir.
right, cool, no problem. So, continue now. So I'm going to say, as x tends to infinity, 9 over x cubed, 7 over x to the fourth, and 2 over x to the fourth will all tend to 0. So therefore, I'm now going to have the limit as x tends to infinity of, that look like 0, of 2 minus 0 over 5 plus 0 is going to be equals to 2/5. So those of you who got that as an answer, I'm really very proud of you. I'm really very proud of you. Those of you, I'm coming back to that. I'm just answer right here. Those of you who got mixed up somewhere, let me just make a continuous page, please. All right, my page is now continuous. So you can see all of question 2 on screen. How you feel? Let me know. Talk to teacher.
Sir, I understand where I went wrong.
Very nice. Very nice. Who's this? Is this Lisa?
Yes, sir.
All right, good job. How about, I think that was Abby. Cheyenne, oh, Cheyenne, you saw your mistake, right one?
Yes, sir.
Okay. Abby, how you stay?
Yes, sir, I got it.
Good job. Alisa, I've not heard from you since class. How you stay?
Sir, I am okay.
Good job. Happy to hear. Brittany, how you stay?
Yes, sir.
You good?
Yes, sir.
Good job. Mr. Bramwell, how are you?
Yes, sir, I understand.
All right, good job. You just sneak to the I class and I don't even say, teacher, what go on, eh? It's all right. Keep it up. All right, let me see now. Who else? Octavia, how you stay, mommy?
I'm okay, sir.
Good job. Bahari, how you stay? Or Bihari, how you stay? Tira,
Yes, sir.
how you stay?
Yeah, right, sir. I understand.
Very nice. All right. Ray, how you stay?
Sir, understand.
Very nice. Now, so based on my canvassing of the class, you guys are understanding. I want to leave. No, Mr. Shan, you did 2 positive infinity. Give them 1 more, and then you're going to ask a question. Now, there is a question that I need to ask of you. There's 1 question I need to ask of you. And it's not a difficult question either, no. It's a question that if you really say that you're understanding, you will see the answer right in front of your eye then. And I'm going to put this other one on the board. Question, this is not it, you know. This is not what I'm asking. Notice that that one says negative infinity. But sir, don't worry about it. It is worked in the same manner as the positive infinity.
Hey, can you repeat that, please?
I'm giving another question to do. What I was saying is just that I'm giving you another question to do. Don't worry about it. What I want you to pay attention to is the fact that this one here is negative infinity. But I'm saying the negative infinity is going to be worked in a similar fashion. to the positive infinity. How so, sir? Just as a little takeaway from it. When I'm raising a negative number to an even power, my result is going to be positive. When I raise a negative number to an odd power, my result is negative. Sir, explain. Recall, negative 2 raised to the third power is equals to negative 8. Negative 2 raised to the fourth power is equals to positive 16. So when you raise a negative number to an odd power, it is negative. So that is a negative number raised to an odd power, your answer is going to be negative. A negative value raised to an even power, your answer is positive. Is that clear?
Yes, sir.
Yes, sir.
So I say,
Sir,
yes, mom.
the answer is, so the answer would be like positive 6.
No, what I'm right. No, not positive 6. What I'm saying to you is that if say, for example, if you're using the intuitive approach, it means that 6, open bracket, negative one big number, say negative 1 million, close bracket, and raised to the fourth power, your answer is going to be positive. So that's 6 multiplied by that number. The first term is going to be a positive term. So let me show you what I'm talking about. Let me use this. Let me use this one instead. So this term is going to be positive. This term is negative. This is an odd number, it is negative. This is an odd number, it's negative. This is an even number, it is positive. What I'm saying to you is, if I'm using the intuitive approach, when I put a negative number and raise it to the third power, it's going to be negative. And I'm gonna, that negative 7 right here, multiply by this negative value here, will end up giving a positive value. So I'm saying to you that the numerator will still be positive. So that is positive infinity nonetheless. And this one here, a negative number, but this x to the fourth is a bigger number than this 4x cubed. So down here, it's still going to be a positive number. So I'm going to get infinity over infinity, which is still indeterminate. That's the point I'm making. Can you see that? Hello?
Sir, can you go one more time again, please?
So what I'm saying to you, whenever we're doing the questions on infinity, remember that it has to be indeterminate, and then we'll move into dividing by the variable with the high x exponent. Remember that?
Yes,
Yeah.
sir.
Good. So what it is, so in these other examples that we did, it's not an issue because we know that we're talking about positive numbers, a positively large number. So it's not a problem because we know when we raise a positive number to a positive number, it's going to come out to be positive. What I'm saying to you, Raheem, that answer is incomplete. The 6 is going to be there, but there's something else. So what I'm saying to you here, when you're using a negative number, you have to still test the waters. But how are you testing the waters? Whenever I'm raising a negative number to an odd power, my result is going to be negative. When I'm raising a negative number to an even power, my result is positive. So I'm checking here in sky blue, I'm checking the real color on North Street. I'm checking, it's going to be 6x to the 4th. This term is going to be a positive term. But if you look in the numerator, which is the largest term?
X squared.
6x to the 4th. So the largest term is going to be 6x to the 4th. So even though that this term here is going to be a negative 25, enough number, this number that is up here, the 6x to the 4th, is still a bigger number than this one. This term is going to end up to become a positive number because when you evaluate 7 times a negative infinity large number, it's going to be negative. but you multiply by a negative number, so it will turn to a positive number. It means that when I evaluate the numerator, my numerator is still positive. Can you see that?
Yes, sir.
Good. When you look at the denominator now, 4x cubed, this is abstract. That's why I'm asking you. Abstract means that it's something that you have to really imagine. 4x cubed is going to be a negatively large number, but x to the fourth is going to be a larger number. Sir, how do you know that it's larger? The mere fact that this is raised to x to the fourth and this is raised to x to the 3. So anywhere you put x here, so this value, x to the fourth, is going to be a larger value than 4x to the third. There's no way, if the value of x is the same for these two terms in the denominator, can 4x to the third be a larger number than x to the fourth? Do you agree with that?
Yes, sir. Yes.
Yeah, man. There is no way. You see, that's why we needed to pay a little bit more attention to our indices class in pre-cal. There is no way in the numerator can 25x cubed minus 7x combined together be larger than x to the fourth times 6. The mere fact, remember, no, this is being multiplied exponentially. You remember when you plotted the graph of 2 to the x, how the graph just looked like a L, and there is no negative value down there. It's an L graph. It don't cut down on the x-axis because it is just exponential. Exponential. And that's why COVID spread so rapidly when we had it a couple of years ago. Because when I sneeze on one person, and that one person sneezes on 2, and each of those 2 people sneeze on 4 more, 4 each, that 2 gone to 8, and each of the 8 sneeze on 2, it gone to 16, and each of those 16 sneeze on 3, it gone to 48. So this is why COVID spread so rapidly, because the spread of COVID was exponential. It was exponential. So sometimes when you hear say 5,000 people died in New York today alone from COVID, it's a blow. 5,000 from one city alone. I mean, to compare the other cities now here, so my goodness, 20,000 people died from COVID in a given day. Yes, it is exponential. So this is worked in a similar manner. Why we did all this exercise, sir? Just to show you that it's still an indeterminate. It's of the indeterminate form. All right. Go ahead now and use a method that you are accustomed to, just like we did before, meaning just like we did up here, so in questions 1 and 2, I want you to go ahead and work question 3 in that similar manner. Give you 2 minutes to finish up that, please. Quick and fast. Whoop, 10 o'clock gone. Come, guys, I have something else to move on to. Quick and fast. How is tea?
Sir, open it up.
Okay. Donald, what is your last name, please? Donald, what is your last name? Okay. I'm changing the names to on the system. You have to have a full name. Malik, what is your last name, please?
Mackenzie, sir. Which Malik, sir? There are two Malik.
Oh, me no know. Hold on there now. You talk again. Yeah, are you
Malik
Malik?
Mackenzie.
You're Mackenzie. All right, hold on, let me just. Brittany, what's your last name, hello?
Atlan.
Atlan?
Yes, sir.
Atlan?
Atland.
Oh, Atlant. Okay. Wait, the one born in Atlanta? All right, nice job. Octavia, what's your last name, please?
Lorling.
Say it again.
Lorling.
Laurelyn.
Ing. Lorling.
Okay, got you. Thank you. Let me see if I have everybody know. If I do. No, I don't. Yes, I do. All right, let's go. I'm going to write the question now. I'm not seeing the correct answer yet, you know. I'm seeing 3 answers in the chat, and those are not correct. Anybody else has another? Okay, Tatiana, you are the closest so far, but can you break it down in slowest term for me, please? Congratulations, Tatiana. Good job, Malik. Good job, Tatiana. Proud of you. The rest of you, come on, come on, come on. We can do it. We can do this. We have it. We have this. All right. Okay, Rian, no problem. Good. All right. So let me just explain something now to you guys. So I have a YouTube channel with all my recordings in. I may be at about, oh Lord, maybe about 100 or more recordings so far from my online lectures. So I'm gonna give you access to we need the access to the online portal. I mean, my YouTube channel, that is, so that you can scroll through. Truth be told, this is the first year in about 4 or 5 years that I'm teaching business calculus. I've not taught business calculus for quite a while. So I do other calculus courses like Calculus 1, Calculus 2, etc. And calculus in the CAPE program. So this is the first in about 4 or 5 years that I'm teaching a business calculus class. So you may only see one set of recordings, and which will be the first set of recordings on business cal. But if you can't find any there, there's always a Calculus 1 class. The Calculus 1 is pretty similar to what we are doing here. But if you don't want to scroll there, I'm going to be labeling this recording as soon as I get it. And I'm going to upload it to the YouTube channel so that you are very free to have access to the recording, so that you can watch the recording over and over until you get what it is that I'm saying. And truth be told, if you ask me, I have a personal preference for online classes. Sorry, COVID came and COVID got me hooked. But when I give you I think I may just put the description in the WhatsApp group so you can look at it. As soon as you get onto the YouTube channel, I'm going to ask that you subscribe so that, and this is not for clout, this is just that, as you know, when I add stuff to the YouTube channel, you can be notified. One of the things that I do sometimes, I make, some recordings and post like recordings on integration, and I send the recordings to all my calculus groups. So if I do like a recording on integration, it's like a voiceover on some notes that I have explaining what is happening. So you can always take advantage of those. What I'm saying to you guys is that I'm trying my best as possible to help you to pass in this course. So I really want you to use the opportunity to just do well and move on to your other courses. Let's see, where am I now? All right, so let's go. So what we're going to be doing is we're going to set the limit. Since it's indeterminate, the limit as x tends to negative infinity of 6x to the fourth over x to the fourth plus 25x cubed over x to the fourth minus 7x over x to the fourth all over 4x cubed over x to the fourth plus x to the fourth over x to the fourth. Again, you'll realize that all of this is now reduced to the limit as x to the negative infinity of 6 plus 25 over x minus 7 over x cubed all over 4 over x plus 1. So as x tends to negative infinity, 25 over x, comma, 7 over x cubed and 4 over x all tend to 0. Oh, come on. Sorry. I'm trying to add a page to this stuff, but it's mm. So if you insist, if you want to be that person, that's fine. Ah, this thing happens sometimes, and it's let's finish a question because this thing is giving me some issues. These things happen sometimes. So the limit as x tends to negative infinity of 6.
Sir, we're not seeing the screen.
Thank you. So 6 plus, sorry about that, 6 plus 0 minus 0 all over 0 plus 1. Which question I give you?
Sir,
No?
you're right.
No, hold on. Am I doing the correct question? So hold on, let me go back to something now.
Yes,
Um,
sir.
Yes, yes.
no, hold on there, hold on there, no. I need to go back to my chat. Akeem, Danica, Jauna, yes, man. You were correct actually. I was looking at the wrong question. I have another question. Hold on.
Sir, so it's
Sir,
6.
is it 6 or 6/1?
It's supposed to be 6. So I don't hold on. 6x to the 4th plus 25. Okay. All right. So I apologize. I was looking at the wrong question. I have 2 questions. The other question is actually 3/2. So I was looking at that question and was saying to you that Donald and Danica and Akeem that you are incorrect. Your answer as 6 is actually correct.
Sir, 6 or 6/1?
6/1 is the same thing as 6. It's the same thing as 6. So as I said before, the other question I'm going to give you, I can't tell you the answer because it's not a secret. The other question I'm going to give you is actually, the answer is going to be actually 6/4. So when I was glancing at my notes before I put it on screen, that's what I was looking at in terms of responding to the question. So Malik and Tatiana, your answers will be the answer for the other question to come. So I apologize for that. Oh, Randy, so you had gotten this stuff and you're wondering where teacher was going down. Yeah, so I was looking at the other question.
I was wondering where I went wrong. So
Yeah, I apologize. As I said before, I was looking at the other question that Norian, you're good man. So the other question, the answer is actually 3/2. 6/4. So that's what I was looking at. So I'm going to give you that question to do, not in class now, because I must move on. But before I do though, I have 3 questions. How many questions are there? 3? I wrote 6 questions for you. So I have 3 more questions to give you. Let me ask you, do you want me to give you the answer as well, or just give you the question? Say it again?
Sir, give me the question alone, sir. Don't give me the answer.
Don't give the answer. All right, no problem.
No.
So, all right, so some male saying something. Who is this? Mali? That's you? Who is saying something? Raheem, what are you saying?
So I say me they have 18/3 and then I divide it and get
18
this.
over 3. No, but 18/3, you shouldn't get 18/3, Papa. How you get 18/3?
So you can me the minus the
Minus times 60 again, that's all.
Say it again. I want to follow what you're saying. Tell me how you get the 18 again.
So I'm do 25 minus 7. And then I put the 2 0, then beside that, and then I have the 4 from the 7, left by the 3. Then I divide them and get the 6 said way.
Yeah, so you don't only get the answer for the mark for the answer 6. I'm going to tell you why. You know that the 25x cube is a different number than the 7x, don't? Because one is cube and one is x. So I can't say to you that I have $10 and 10 pounds sterling and I have $20. Talk truth.
Yes.
Yeah.
Yes.
Yeah. So I can't say I have 10 euros, I have 10 pounds, I have $10. I have $30. No, I don't. I have to bring all of them to a common unit. So either I'm going to carry all of them to US, to pound, to euro, to Canadian, to Jamaican. I have to bring them to a common unit and then tell you how much money I have. Just like this, I can't say 25x cubed and subtract it from 7x. They are 2 different terms. They share the same variable, just like the something. The $10, dollars is a variable. Dollars is a variable. But you have to know the $10 is a different, the US now is going to be different to it because the $10 is the same unit, but the US is going to be different. The Canadian and the pound and them something. So I can't do that. That step in and of itself is illegal. So I want you to correct that for me, please. I want you to correct that for me. It's keep inserting the page, but it's inserting a page above and not below, and my cursor is where it's supposed to be. I'm going to stop share again, please. All right, so what I want you to do for me, all of you, you have it in your books. I want you to look at the 3 questions. Look at the questions. Look at the answers that you would have gotten for all 3 of them, and see if you can come up with a rule. That was what I asked you last class. Look at the questions, look at the answers, and see if you can come up with a rule to just look at the question and maybe tell me what the answer is going to be. I give you 3 minutes. By then I'm supposed to figure out what is happening here with the system.
Sir, if the rule contains something about negative and positive, just ask.
No. No. But continue trying. Shy. It appears that I can't add the pages while I'm sharing the document, because as soon as I stop sharing, my other pages were successfully added. So in future, just remember that that is so, please. All right. Let us go back to question 1. I'm going back to question 1. I'm reducing it so that we can have all of question 1 on it. I'm going back to question 1. Can you look at the answer and look at the question and see if you can generate the answer from it by just looking at the question? All right. No response, so that is going to be your homework.
Check with the scroll up. So I think you can look one question from the second line, so when you have eliminate.
Yeah, man, finish your statement. I'm sure you're not finished right there, so talk to me. All right, let me scroll down to number 2. Is it the same? Is it the same idea for what do you think the answer is for number 2 then?
Sir, I think I kind of have it, but when I look at number 3, it's kind of confusing. I was thinking the first 2 terms for the denominator and the numerator.
Okay, and again, pause it right there. Again, pause it right there, Randy. So that was a very reason. That was a very reason, because you're seeing that there. You're seeing that one there. And that was a very reason I wrote number 3 the way I wrote it. That was a very reason, because I didn't want you to leave it that thing. So go again. So look back at your notes. That was a very reason, Randy, that why I wrote question 3 like that, so that you don't move away with that notion. But you're getting warmer though. You're getting warmer. Talk to me. Look at your notes. I'm going to write the 3 homework questions for you.
Sir?
Yes, please.
Yes, please. Sir, is it that any whole number will become the answer?
Which whole number?
Sir, like for the last one, the 2 whole numbers were 6 and 1, and then the other numbers that were over x or over x to an exponent would have been equal to 0.
Almost, but not fully. Almost. It means that you'd have had to do 1 line first before you can get that. But I want you to just see the question and able to tell me what the answer is. For example, Wita, you were just talking to me. What is the answer for number 1 homework here?
(6/4).
I'm going to reduce that to get.
3/2.
Okay, how did you get that? That's correct, but how did you get it?
Sir, I don't know how to answer that one.
So basically,
6/4, she divide the both numbers by 2.
Okay.
Sir, so
all right.
basically, sir, are you saying that any number you get for your answer, you have to divide it to get
I'm not saying anything just yet. Look at number 2 and tell me what the answer is.
3.
Aha. So you're saying the same thing like what Randy is saying. So that
sir, so you can get without doing the question, you can get the answer from the number from the first coefficient.
It's not the first coefficient, no. So it means that you're not seeing the rule yet. And I'm not going to tell you the rule.
Sir,
What's the answer?
Yeah, so like any number of the coefficient automatically equals 0. So when we factor like the x7 now factor it out to have 6/4 left. So automatically the 5x3 and the 9/x would equal 0.
So what is the answer for number 2? That's what I'm asking.
Sir, does it have something to do with the exponents, like the power that x is being raised to?
It sure does.
So the ones with the same exponent would be the answer?
What's the answer for number 2?
3/1?
No, that means you're not seeing it yet. No.
Would number 2 be 7/2?
Duh, no. Almost close enough. Almost close, Cheyenne. Almost. You're like a centimeter away from the correct answer, but you're
Would
seeing
it
some.
be 3 and 1/2?
3 and 1/2 is the same thing as 7/2. Go again, Cheyenne. You're missing one little something. So if all of you just follow what Cheyenne is saying and just help her to correct one little something.
So would it be -7/2?
Very good, Makeda. Very nice. Cheyenne, you say, oh, you give Makeda the answer?
Yeah, because you have the minus in front of 7.
Very good. All right. Now, Makeda, Cheyenne, what's the answer for number 3?
Two over one.
There would be 2/1.
Excellent. You guys see it. So you no need to tell the no, don't tell the others. Make them figure it out. Don't tell them. All if you're a good friend, make them figure it out. This is mathematics is fun, you know. And it don't make sense. I come to the classroom and give you all the rules. Because if I give you all the rules, there's no way you're going to develop into critical thinkers. And I want you to become critical thinkers. So hold it close to your heart. And if they come to you and ask you, is this how you do it? If they're wrong, correct them. But I don't want you to tell them. Very good, a pair of you, for seeing what it is that I want you to see. All right. With that said, I've ended that. And I'm moving into another area. Very nice, Cheyenne. Very nice, Makeda. Proud of you guys. You did very well.
To the questions.
Say it again. No, I'm going to send you the document. I don't want you to write the question. I'm going to send you the document and finish. Well, let me just go do this and then just write down here because I really need to touch. I have to start this one. New topic. Waiting on you to let me know that I can begin. Those of you who are taking up the homework, that is. Can I go?
Yes, sir.
All right. So we have about half an hour. Oh no, we have 20 minutes left. I can introduce the topic in 20 minutes. Not a biggie. I can. So let's go. Remember, I'm gonna send you the document. You've been doing very well. So Normally I say to students, write in my class. When you do very well and you respond to me and you talk to me in class, you know, it's an incentive for me to send you what it is that I'm writing, because I send you to the recordings. So I'm going to send you this because you've been a good set of students today. So I will send you without any second thoughts. So piecewise function. Piecewise function. So if I ask you to all right. So that's my function. Now we're going to have a conversation. The question is not a difficult one. Okay. Malik, you're not hearing me? Anybody's hearing me?
Yes, sir, I'm hearing you.
I'm hearing you now, sir.
Oh, you hear me? No. Okay. So hold on a minute, please. All right. So the question says to determine if f of x is continuous at x equals 2 and at x equals -2. Let me just give you a quick concept. I teach this topic differently than how some others would teach it. And there's a reason that I do it this way, because I really want you guys to get something here. Work with me. If I'm doing this, how would you describe me drawing that line, that curve? Versus,
Continuous.
very good. How would you describe me drawing this line?
Incontinuous.
Okay, so the word is going to be discontinuous. And there are several points of discontinuity right there. There's a point of discontinuity right here. Can you see this gap, these gaps right here?
Yes, sir.
So those are going to be the points of discontinuity. What are the points of discontinuity? Would be points such as this. So those are the points that we're investigating to see if the point is continuous at those points, right? So if it is continuous, you will have a constant wave, a constant curve that is being plotted if it is continuous. If it is discontinuous, you're going to have breaks in the graph. And the truth of the matter is, in real life, you see, just like what we did a while ago with the limits of the function, and you can look at the question and tell you whether or not the function is going to be continuous. I can look at this question and tell you, say, boom, the function is continuous. Sir, how? I'm not going to tell you. I'm going to guide you so that you can discover. This is called discovery learning, and this is what makes mathematics fun. Math can't be fun if the teacher tells you everything. The teacher is going to lead you, and we're going to carry it close to the water, and the teacher can say, yeah, man, try again. Boom, yes, Makeda, yes, Cheyenne, you catch it, right? And those two students are now feeling nice because them leave the maths class today to catch something, right? So it is fun. And if you don't catch it by next class, of course, I'm going to tell you. But I don't want to tell you right up on that because it means that you're not going to be able to think about anything on your own because we tell you everything, right? So I want after class, you're still thinking about what it is that we would have done, and come next class, if you don't catch it, I don't want to frustrate you. So I'm going to tell you, and they say, for real, sir, we see it now, right? And then we'll move on to another activity, such as piecewise function. So just bearing in mind, as I said before, I teach this differently than how others do. So if your other friends from the other calculus class don't reach here, so, or the teacher started differently, there's a method to my madness, right? So work with me. So if you can draw a curve without lifting your pen or your device, pencil even, it means that you have a continuous function. If on the other hand, you are drawing and then lift very briefly and then go back down, it is going to be discontinuous because there's going to be a break in the graph. Sometimes the graph just cannot exist right there because there's no real value. So sometimes when you put on your calculator math error, those are the math errors we're talking about. Those two purple circles are the math errors. Yeah, that like a glasses, but anyhow, that's Malik glasses, right? So it's going to be math error. There is no way on earth can those values exist. So we are checking to see if f of x has any such values that like this that we can look at, or can we conclude that, hey, all of this is continuous everywhere. All of this is continuous everywhere, right? We're going to look and we're going to double check. All right, sir. We have 10 minutes. Can we finish this in 10 minutes? Absolutely. Come. Don't write. Just look at what I'm doing. I'm going to send you the stuff. So I'm going to be investigating G's on P's. This is where we're going to look at the intuitive approach. So can you read me this sign? This says X is what kind of -2? The top one up here. Look at the cursor. What is this saying? X is?
Less than -2.
Excellent. X is less than -2. So when it is less than, give me a number that is less than -2.
-1.
Really?
No.
-3.
-3.
-4,
-3. -3 because so less than means it's going to the left of -2. That's what it means. Technically, you're going to the left of -2. That's what it means. Watch me now. So because we're going to the left of -2, we are selecting -3. Then, sir, you have to use -3? No, you can't use -4, -5, -6, -7, negative anything, but you can't use you can't use -2 because it's less than -2. And you can't use -1 because -1 is going to be greater than -2. So you select a number that is to the left of -2. And you're going to say, for argument's sake, you're going to evaluate your limit. But remember now, so this is going to be that. So remember when we're doing the calculations method, what it is that we're doing, we are assuming that x is going to be equal to 2. That was assuming that x is going to be equal to 2. So what we're going to say is the limit as x tends to -2, and I put it a minus there. That minus means to the left. Who was that young lady that asked me if x could be, if 0 could be negative? What's her name? Anybody remember she asked me the question and I stopped class and answered? I think that was on Tuesday. Anybody remember? All right, let's go. So this is where we are now. So we're looking to the left of it. And to the left of that is going to be this function 2x, and the value of x is going to be 2 minus 1. 2 times minus 2 is -4. -4 minus 1 is equal to -5. That's what we're getting. To the left, we're saying that the limit is going to be -5. Remember, when we're calculating the limit as x tends to -2. We're going to look to the left and the right of it. But in this particular case, we're looking to the left. And to the left is anything from -3, -4, -5, -6, whatever the situation is. That's if we're doing the intuitive approach. But what we're doing now, we're just going to assume that x is equal to -2. Plug it into the function, and we're getting out -5. All right? So this is for the -2, the less than -2. Let me just change something, even though this is not incorrect. Let me just change something right here, and just write this less than, and we're looking at x equals -2. That's what I'm investigating. I'm investigating when x equals -2, the -2 component. All right. So let us continue. When we look at this double not integral, forgive me, this double inequation, that's the I word I'm looking for, the double inequation. There are two parts to it. There are two parts to it. Part 1 is reading from here. That is part 1, reading from there. And part 2 is reading from here. So when we're reading, we're going to read inside out. Inside out. Starting from the x to the left, starting from x to the right. We're reading inside out. So from the left, we're going to be x is greater than -2. So what we're going to be looking at now, x is greater than -2, we're going to look at the greater than sign. I'm still looking at the one with the x equals -2. So with this time now, it's greater than, so we're going to the right. So give me a value that is greater than -2. Let me see if you're thinking.
-1.
Very good. Very nice. -1. So I'm going to say now the limit as x tends to -2. You see why I put the -2 right here, so? And here, so? Because that's what we're investigating. All right? X tends to -2. To the right this time. So I put a plus sign. I'm going to the right. So I put a plus sign. I go to the left. I put a negative superscript. And I go to the right. I put a positive superscript. All right? So let's go. So when I look at it now, I recognize that this piece here has x -3. So to the right of it is going to be x -3. So what I'm going to do is to say x, which is -2, -3. And -2 minus 3 is going to be equal to -5. Wow, look at that, sir. So I can say since the limit as x tends to -2 to the left of 2x minus 1 is equivalent to the limit as x tends to -2 to the right of x -3, comma, then f of x is CONTINU OUS at X, no, at X equals -2. Remember we said the last time that it was of a good behavior and both of them had to be the same in order for it to exist? Anybody remember that?
Yes,
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 sir.
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 Good job. So because both of them are working out to be -5, we say that the limit is of a good behavior. Yeah, man. So we can just simply write, since the limit as X tends to -2 to the left is equal to the limit as X tends to -2 to the right, then f of X is going to be continuous at X equals -2. So when we pass that critical point at X equals -2, we're not lifting at all. It's going to be a continuous curve. All right? And quickly, let us see if we can just squeeze in the other part. Now we have two things. We have X equals -2, see it here so, and we have X equals +2. So we now need to check to see if it's going to be continuous at X equals +2. We also have two functions. Watch me. You recognize that this same function, X minus 3, work with the same -2 and the +2, talk truth.
Yes, sir.
Good. So what we have to do now is to say, oh, but sir, so we work inside out. We start with the X, we work so to get the less than. You recognize that when we're talking about the less than is going to be to the left. See it here? I am going to the left because that's less than. Now I want to go to the right. You see where I'm going? To the right. So I'm going to investigate what is happening now at X equals 2. But remember, X equals 2 to the right. Sorry, this is to the left. No, this is less than, right?
Yes, sir.
Good. So this is less than. Good. So less than is going to go to the left. But remember, this arrow here is suggesting that I'm reading my inequality two ways. One going this way and the other one going this way. But this other limit now that I'm going to be investigating is to the left. So I'm going to say less than. I'm going to say less than. Remember, less than, which is this, goes to the left. So I'm going to evaluate here the limit as X tends to 2 to the left of X minus 3 is going to be equal to 2 minus 3, which is equal to -1. And that is to the left. We now need to investigate what happens to the right. What happens to the right? Which equation do we use for the right of 2? Which equation do we use for the right of 2?
Is it gonna be 1, sir?
No, which equation? Tell me the equation. Tell me the function.
X.
Tell me the function. There are 3 functions of f of X. Tell me the function that deals with when X is greater than 2. Or, yeah, when X is greater than 2.
X minus 1.
X minus 1, duh. Yeah, man, X minus 1, see here? X is greater than 2. So that one deals with X minus 1. So that's what the first one was a less than. So greater than now. So greater than is going to go to the right. So what I'm going to say is a limit as X tends to 2 to the right of X minus 1. Anywhere in the function I see X, I'm going to put 1. It's going to be 2 minus 1. What do I get?
1. 2 minus 1, 1.
2 minus 1 is 1. Very good. So I'm going to get, oh, let me just carry this up a little bit. So I'm going to get 2 minus 1, which is equals to 1. Is that function continuous?
No, sir.
No, sir.
Very good. And that's my last statement before we end class. I'm going to say, since the limit as X tends to 2 to the left of X minus 3 is not equal to the limit as X tends to 2 to the right of X minus 1, comma, then f of X is DISCONTINUOUS at X, nope, at X equals 2. And that's the end of the question. This is a must-have on the exam. This topic is also on the mid-semester. Must-have, sometimes it comes for 5 marks, 6 marks, 7 marks, 8 marks, 9 marks, 10 marks, depending on the function. This is a must-have. All right. It's now 2 minutes past 11. I'm going to convert this document to a PDF. I'm going to send it off to you. I'm begging of you guys, go through your Educasoft, go through this, what it is that we have just done in class, review it before next class, and if you do that, you're good to go. Fair enough?
Yes,
Yes,
sir.
sir.
Thanks for
Sir.
coming out. Yeah, man, go ahead.
So I'm not on Educasoft. I didn't receive an email.
All right. Oh, you're the one who put it in the WhatsApp. You weren't in class. This is your first class?
No, sir, this isn't my first class, but I didn't realize that the WhatsApp group was sent in the pre-calculus group until the day that I sent that message.
Okay, then. All right, cool. So just send me a message in this new WhatsApp group with your email. And for those of you who are here for the first time, not on Educasoft, I'm going to ask that you send me, first you need to get connected to the WhatsApp. So I'm going to ask somebody to just send the link so that you can just join by the link for the WhatsApp group, number 1. And in the WhatsApp group, you're going to send me your email address so I can get you connected to Educasoft. And what I love is if you're talking to me, get my attention in the class WhatsApp group first. Sir, good morning. I sent you a private message. So I can click on that message and get directly to your message. I have scores upon WhatsApp messages that come in on my phone that I don't have any name attached to it, and I don't know who is who. So before, don't come and say, sir, I send a message and you don't respond. Put it, get my attention in your WhatsApp group so I can move from your WhatsApp to your direct message so I can respond to you. All right, I don't want to keep you from your other class. I have a meeting from 9 o'clock, so I'm just going to join them now. Have a good one. Talk to me in the WhatsApp group if you have any other questions. All right? Have a good one, guys.
Yes, sir.